Welcome to part 2. See, now systematic approach or procedure to find I will write technically required cross-sectional area of longitudinal reinforcement. I already told AST and ASC both are longitudinal reinforcement. One more comes stirrups, that is called transverse reinforcement later. That is means what is the meaning of that one? That is to find AST required if cross section is designed as, don't write Sri, I am saving time here. You should not do that way. Cross section is designed as singly reinforced, it is a verb. And to find AST required and also ASC required if cross section is designed as doubly reinforced. That's what you are covering. See, data. B should be known. D should be known. FCK, FY also known. Along with that one, in case it comes singly, that's all. Right here. This is for singly. See, this is for singly. For Sri. Whereas this is for doubly reinforced. Means if it is doubly reinforced, all this data required, apart from that one extra, that is D dash. Remember, I am going to put the sketch here. What I do is, to understand correctly, I will use green color for unknown. Unknown, that is what you are finding, our class. What is the most important is, that is, I will do one thing now, see, AST required, I will color here, AST required and AS required are green color throughout my course. To understand correctly, I will maintain green color, but writing is, okay. Now start. First, data is known. Now, first of all, these all I need not give. It is already known for people. Still, to make perfect, if the BM is sagging, this is for hogging, I forgot right here, okay. Yes, we have full, these both are for sagging BM. See, this one and this one both are for sagging BM. Whereas this one and this one both are for hogging BM. See, if BM is sagging, extreme compression at the top, AST here. This is if it is singly reinforced, only AST. Same, this is XU from extreme compression edge. D all you already know it, I need not explain. If you want, you can write width of the beam, cross section of beam, effective depth, distance from extreme compression edge to center of tension steel, FCKFY and D dash, effective cover to compression steel whenever it is applicable. You can write if you want to make fair copy. Okay, now, if doubly, all that in singly will repeat. See, once again AST, everything same, but extra D dash from here. Now, or if the BM is hogging, top tension, bottom compression, this is extreme compression edge. Singly means only AST here. This is D, this is XU. Doubly means AST at D, XU as usual and D dash. These are the requirement. So when you solve a problem, you write the applicable sketch right here. When you solve a problem, write the applicable sketch. One more thing, you observe one thing here. Singly or doubly, sketch will be same. Only thing is, if it is doubly, one extra will come here. See, this extra. This is the extra. AS is the extra. Therefore, when you first put the cross section, you should write all these things. You are not knowing singly or doubly. Write the sketch for singly. Do not show ASC. You write B, D and AST. XU is not required and AST. That right. Later, when you decide singly or doubly, if singly, proceed further. If doubly, write one more sketch if you want, where you show AST and also ASC. That's how, or that is the way I will proceed further in the class. Okay, now I will remove now. I will continue the procedure. I have not written anything. I will write in front of you only. Now, one thing forgotten. You add it now. First data, B, D, F, C, K, F, Y for Sri. Later, if doubly, you require D dash. But also, factored BM to be resisted by cross-section MU is known. Otherwise, there is no question. I forgot to tell earlier, I told before writing this part, last part I told MU is known. Okay, then what to do is, first, I forgot now, based on Fy, get XU max by D. Red color. XU max by D is always red color. Get XU max by D. Okay. Then, see, I write here. Then, very clearly I will explain. Then, what we have to do is, I write here, then required to decide whether, full I am writing, whether cross section is to be designed, actually I am repeating, to be designed as, full I am writing, singly reinforced, SR, I won't put SRI, singly reinforced, or doubly reinforced. First you have to say, reinforced. Right. Then, if, now I will give shortcut, if singly reinforced, we have to find A, see, now I will push color, unknown. Unknown is what? We have to find unknown. AST required. Whereas if doubly reinforced, we have to find AST required. See, RCC means beams. AST is always there. AST required, and also ASC required. And also ASC required. Then D dash is also required. Then you require D dash is also required. Okay. This is the steps. Now, how to decide? See, earlier I told you in the previous part. Now systematic way. Okay, now how to decide? First find limiting MR for singly reinforced. See, whether you want to singly or doubly, whatever it is, first find limiting MR for singly reinforced rectangular balance section. That is MU limit. Right, formula. MU limit equal to MU limit equal to 0.36 into XU max by D into bracket 1 minus 0.42 into XU max by D at the red color. Okay. Leave it. Full group is red. XU max by D into B into C D square. It has got a structural meaning into FCK. Okay, then therefore substitute and find MU limit. Now make a note. One note you can write here. Note. Now we know MU what is the factored BM to be resisted by cross section, and also we know MU limit. How much maximum factored BM cross section can resist if it is singly reinforced. Right, if you want this much, right? I'll continue procedure. So remember, when I continue the procedure now, MU known, MU limit known. Still singly doubly not decided. Next step. Compare, continued. Procedure continued. Compare MU with MU limit. 1 minute. I should ensure it has not gone out of camera. Too much upper side I wrote. Just 1 minute. Oh, no problem. It is within the limit. MU with MU limit. Okay. Now, see, correctly understand. Actually not required. Now, then I write case 1. Case 1. MU comes less than or equal to MU limit. Okay, to make fully clear, I will write here. Meaning, once again, not required. Factored BM to be resisted by cross section. Resisted by cross section. This is maximum. I won't use a technical term now. Limiting MR I will not use. Maximum factored BM cross section can resist if it is singly reinforced. Singly reinforced, of course, balanced. Balanced, to understand correctly. Common sense will tell. If the bending moment is lesser than how much singly can resist, why you want doubly? Doubly is required when you want additional strength. Therefore, suppose, see, imagine, bending moment is 100. MU limit is 150. If the bending moment to be resisted is 100, singly can resist up to 150. So, singly only. Therefore, in that case, then cross section is to be designed as singly reinforced. Singly reinforced. Therefore, we have to find, 1 minute, singly reinforced, of course, also it will be under reinforced. Under reinforced when your MU is less than MU limit. Okay, red color. Okay. MU less than, to understand, under reinforced. I will tell the reason for if you want. See, 1 minute to understand. Don't write all this one. Singly reinforced section as a balanced section can resist 150. Steel required is, imagine, 1400 mm square. AST required. Okay, now, but actual BM to be resisted is 100. So therefore, to resist a BM of 150, steel required is 1400. You require only 100 kN. Steel required may be how much? It is not linearly proportional. Some random number I write here, 986. It is not linearly proportional. So, somebody may question, how you got some number. So, the steel required for the cross section is less than that required for a balanced section. This only will tell you it is under reinforced. Which under reinforced, which is the what? Best section. Under reinforced is the best section. Reason I told, 1 minute. Reason I have not told too much. One star class I told, I will take that class with a lot of concept. Condition I put earlier. Minimum 100 comments required, 100 requests required in the comment box for that one. Nobody is putting any comment and nobody is asking. If you do not want that concept, why should I waste my time? But basic course I am conducting systematically. Extra information, if you are not asking, why should I give? Okay, now, over. Now, or you can remember, singly balanced is, imagine your own capacity. Suppose you have 1,000 rupees with you. This red color, okay, limit 1,000 rupees. This is the limiting bill that you can pay. Suppose the bill comes to, MU is what? How much bill you have to pay. This is how much maximum you can pay. Suppose the bill comes to 850 rupees. Yes, you can easily pay. Singly reinforced only possible. You do not require any extra help. Extra help means doubly reinforced, ASc. So remember, now next case is, I will tell you now only, MU more than MU limit. Suppose you require 1,400 rupees. Bill came 1,400. You have only 1,000 rupees with you. Oh, the bill came more than how much you yourself can afford to pay. The bending, next time, not now. The bending moment is beyond the capacity, so extra help required. That extra help will be doubly reinforced. ASc will come then. Okay. This is just to understand. Okay, now, I told cross section is to be singly reinforced. Therefore, we have to find, 1,000 will remove. We have to find only what? Unknown. AST required. AST required. Now, how to find it? Find AST required by the relation by MU equal to MU. 1 minute. Make those who want, make a note. Singly reinforced and under reinforced. Those who are serious right there. Singly reinforced and also under reinforced. So, you can use the equation for MU in terms of tension. I already explained earlier. Or if I take star class, I will tell more concept. Okay, MU equal to 0.87 Fy. Use IS code equation. Don't use that equation D minus 0.42 XU. Use IS code version. Design problem, always use IS code equation. Fy into AST into D into 1 minus AST Fy divided by BD FCK. Use. Substitute. Everything is known. Substitute. We get a quadratic equation in terms of AST. See, you can see here. AST into AST, AST square and AST into 1 equation. Then, equation. Solving, we will get very important 2 positive values. So I'll put here. We will get 2 positive values. Very, very important. See, important values for AST. Now, which one to consider? 1 minute. I will go out of subject for few minutes. Imagine, okay, I will somewhere here. Those who want to write a note outside. See, suppose you consider strength of materials, not RCC, or engineering mechanics, or structural analysis. That is my most favorite. And in YouTube, I am conducting systematic course for that one only. Mechanics, SOM and structures, each with around 100 classes. Continuously, I will start uploading the classes. Little, coming up slowly. And even systematic notes also will be given for those who want it. Conditions I will write at that time. I will tell at that time. Okay, now, I am making ready for that one. After all these courses are over, I want to teach everybody, entire world, systematically basic subjects, mechanics, then what? Strength of materials and structure analysis. If possible, matrix method and FEM also. And some dynamic analysis. Depends. Structural dynamics. I will decide later. Okay. Now, start. One time being, you tell, hey, AST, please wait. I told you will get 2 positive value will come. Right here. One note right here. Note. Doubt will come. Doubt. Which one to take? Which one to consider? See, because both are positive. Both are positive. Doubt comes. Okay. You tell, wait for some time. Time being, leave the subject, go to basic subject. See, for example, suppose there is a simply supported beam with UDL. I will draw BMD on plus upper side. BMD will come if this is a BMD. Suppose the span is 6 meters. That I not require. This is called point of contraflexion. See, I will put point O, point of contraflexion. I will take it as X from here. This is 6 meters. So 100% sure X is less than 6 meters. That is guaranteed. Okay, now, how to locate? You write expression for bending moment at O in terms of X, where X square will come. See, reaction into X minus UDL into X by 2. It will give quadratic equation X square. Solving, you will get 2 values for X. 2 values for X. Remember, it is structural basic subject, not your RCC. Which one to take? If one value comes, you can make a note. If one value comes, usually what will happen is, sometimes one value will come positive, other will come negative. You should write if you want. Take positive value. Okay, done. But so many times what happens is, both will come positive. Both will come positive. Which one to take? Take the applicable value, because 100% sure it is less than 6 meters. If one value comes to see plus 4.5 meters, other will come 21.6 meters. See, your point lies here. It cannot go beyond this point. I will take A, B, C, D. A, B, C. It has to lie between A and B. So this is not applicable. Take 4.5 meters. I will ask the class which one to take. Sir, least value. Don't tell least value. Take applicable value. Now I will ask the question. By chance, if both the value comes applicable, what to do? See, last question I will ask. Suppose when you solve this one, you get X equal to one of the value 1.2 meter, other is 4.6 meter. Which one to take? Student will tell, sir, if I look here, it's 6 meters, sir. This looks like more than 3, 4 meters. Then I will tell, diagram need not be that way. Sometime diagram can be like this also. See, it's a high value here. It can come this way also. It can come somewhere here. See, it is possible that some rare cases, it can come this way also. Curvature, one second, need like that, because I don't want to make mistake here. Some rare cases, even the diagram can come this way also. See, it can be here also. There is no, don't tell me, suppose you don't tell those things all. Which one to take? You should not tell by looking at the diagram. If both comes applicable, what to do? Then they will tell, sir, we don't know, you tell. I will tell one statement then. I will tell, in strength of materials or structural analysis or in even engineering mechanics or even in what? Even in matrix method or etc. If when there is only one applicable value, if two value both are applicable, what to do is, I will tell, throw everything outside, leave structural engineering, don't continue. and I will stop my teaching right at that time. I will tell it will never come. Sometime I use the very arrogant word also. No beam in the world has got courage to give two applicable values of point of contact flexure when only one value is existing. No beam has got courage. Of course, little arrogantly, because I am 100% sure, right at that moment, I will stop my teaching. It will never come. I know it. So therefore, it will never come. Leave it now. But here, this is not strength of materials. It is RCC equation. Which one to take? Two both value will come positive. Right here. Then, most important, two positive values for AST. Consider least value, which is the applicable value. Suppose when you solve, you get AST equal to one value 696.8 mm square, comma positive. Other one is positive 20,468 mm square, right? Taking the least value, AST is 696.8 mm square. Now, reason. In the course, I told the reason. For you, I don't feel like telling the reason because, first of all, before this one, reason for star is more important. You have not shown interest for a basic concept only. So why should I waste my time? So I am telling you, you take the least value. That's all I can tell. If at all I take the star class later based on sufficient request, then I will explain this one also. That depends. So therefore, make a note here. Solving quadratic, two positive value will come. Consider applicable value. Okay. 1 minute now. Just a minute. Okay. Remember, you should write everything correct order. See, I told compare mu with mu limit. Already case 1 over. When mu comes either less than or equal to mu limit. I told singly over. Now case 2, mu more than mu limit. Then what to do? I won't write anything because I won't write systematically here, everything. It will come in the next part because already I saw there it is taking more than around half an hour now. So if I continue, it will take more than 1 hour. Unfortunately, beyond 45 minutes, I cannot record in this camera. So then I have to join the videos. No, I don't want to join that way. So leave it. So part 3 coming up immediately now. Most probably part 2, part 3, I will simultaneously upload. So that, but you should write everything in correct order. Don't write part 1, part 2. When I go to part 3, I will tell you. When mu is less than mu limit, what to do? Already told. Now, but I write once again, what is mu limit? But you know the answer. Cross section is to be designed as a doubly reinforced. We have to find not only AST required, also AS required. See, AST required, just one equation. Doubly means not that way. Procedure is long. You have to write mu minus mu limit equal to FSC into ASC into D minus D dash. To get FSC, you require epsilon SC equal to 0.0035 into XU minus D dash by XU. Then you have to find ASC. AST you have to find by AST1 plus AST2. How to find AST1, AST2. All will be told systematic way. It will come in part 3. That is, you write everything, continue. You write this way and continue procedure. You never differentiate part 1, part 2, part 3. All 3 single fair copy you should make. Okay, we'll meet in part 3 now.